Now we want to look at doing the opposite of multiplication, and that would be factoring. When we factor, the first thing that we do is we look at all of the terms that we have and we divide out or we factor out a common factor. So you want to look for what they have in common. And we notice that sine alpha and sine alpha is common to both terms. And it's important that not only the trig function have the same name, but also the input must also be the same. So we must have an alpha and an alpha in order for us to say that we have a common factor of sine alpha. So the input is also important. It must also match. So both of these terms have a common factor of sine alpha. So we'll divide out or factor out to the front that GCF of sine alpha. And on the inside, we would have left cosine alpha minus secant alpha. If we wish to factor sine squared theta minus 1, we have two separate terms, and both of these would be what we call perfect squares. So we're going to think back to algebra when we factor something called a difference of squares. And when we're factoring, let's think about, back to algebra, think about back to this example here, x squared minus 1. When we factor that as conjugates. So it's the first term, whatever I'd have to multiply times itself to get x squared, which would be x and x. Basically thinking about the square root of x squared, and the square root of 1 would also be 1, and we put opposite signs in between. So difference of squares always factors as what we would call conjugates. So if I'm factoring sine squared theta minus 1, we will also factor this in a very similar way. But instead of putting x, what we're going to put in the front of both would be sine theta. Sine theta times sine theta gets me back to sine squared theta. We will have opposite signs in between, and then we have that 1 for the last two parts of our parentheses. Now we want to factor 4 times tangent squared beta plus tangent beta minus 3. Once again, I would encourage you to think back to your days of algebra. And every time that you see a trig function, you can start to think about that as being sort of like x in algebra. So we can say that this is similar to the idea of factoring 4, and instead of thinking of it as tangent squared beta, let's think of it as x squared. So that's like x being squared, and plus tangent beta, let's think about that as x minus 3. If you were to factor that in algebra, what would it look like? Well, that would be 4x and x. The signs would have to be opposite, so let's say minus and plus, and then we would have 3 and positive 1. And let's check it to make sure that this gives us back what we want. First times the first gives us 4x squared. Outer times the outer gives us a positive 4x. Inner times the inner a negative 3x, and then last times the last a minus 3. So when we combine the two middle terms, we get positive x. So that's how we would factor that in algebra. Now what does it look like in trigonometry? Very, very similar. We're still setting up our two parentheses for those 3 terms. And instead of having 4x, we're going to have 4 times tangent of that angle beta times tangent beta. Plus and minus, so we have minus 3, and then we'll have plus 1. So wherever we had x before, now we're just using tangent beta. And of course we can always check that. So let's check. First times the first gives 4 tangent squared beta. Outer times the outer gives positive 4 tangent beta. Inner times the inner is minus 3 tangent beta. Last times the last, negative 3. And we see that the two middle terms would combine to give me positive tangent beta, which is exactly what we started with. If we want to factor cosine to the fourth x plus 2 cosine squared x plus 1, we're going to think back once again to algebra. So we're going to think about what this is similar to. If we were to factor, so we're going to take cosine raised to the fourth power of x, and we're going to represent that as, let's say, like y. So let's say y to the fourth plus 2 times, and this is cosine squared x, so let's think about that as a variable squared, so y squared plus 1. If we were going to factor that, we would use the same process. We would use reverse FOIL. We have y squared, and both signs are plus, and we would have to put a 1 in the back of both. And of course we can check this to make sure that it really does give us what we want, but this is how we would factor in algebra. Now how are we going to factor in trig? We're still setting up our two parentheses for those three terms, but instead of putting in x, we would now put in cosine squared x, very similar to how we did y squared, plus 1 and plus 1. And let's check that on the trig version here to make sure that if I multiply these back together, cosine squared times cosine squared would be cosine to the fourth x. Outer times the outer would be plus cosine squared x. Inner times the inner would be plus cosine squared x. And then last times the last would be plus 1. Our two middle terms would be like terms, so we can combine those to get 2 cosine squared x plus 1. So this checks out. So our final answer here for the factorization of that trinomial would be cosine squared x plus 1 times cosine squared x plus 1. Now we wish to factor sine raised to the fourth power of x minus tangent raised to the fourth power of x. If we think back to algebra, this would be similar to, and we're going to replace, let's think about thinking of sine as a variable like x to the fourth, and tangent as a different variable, let's say y to the fourth. This would be a difference of squares, and we could factor this as conjugates, x squared plus y squared, x squared minus y squared. But the first one would not factor anymore. That would be prime. Sum of squares is prime. And then x squared minus y squared could actually factor down more as x minus y and x plus y. So that would be our complete factorization of that in algebra. But in trig, we're going to do something very similar. So we are going to think about this as a difference of squares, and we will first factor this as sine squared x plus tangent squared x times sine squared x minus tangent squared x. So initially it factors as those conjugates, but then anything that can be factored down more, we would like to factor it more. The first one is like a sum of squares. That will be prime, so we will not factor that anymore, but we still need to bring it down. And then sine x minus tangent x would be the factorization for the difference of squares. And then that would be sine x plus tangent x. So this would be the complete factorization, very similar to the complete factorization that we would have done in algebra.